In my earlier video, I had told you many times. Now I will discuss linear algebra as a review. So I will discuss as a review many questions. At first I will discuss one question which had come CSIR NET June 2015 exam. This type of question actually based on minimal polynomial, diagonalizable, annihilating polynomial. First question. Consider AB n cross n matrix which satisfies a to the power k equal to in, where I be the n cross n identity matrix, where k is the positive integer with greater than k. Suppose 1 is not eigenvalue of the matrix A, then which of the following statement are necessarily true? Option 1, A is diagonalizable. Option 2, A plus A square plus this would be continue a to the power k minus 1 equal to 0 matrix, where option 3, trace of A plus trace of A square up to trace of a to the power k minus 1 equal to minus n. Option 4, a to the power minus 1 plus a to the power 2 plus up to e to the power minus k minus 1 equal to minus identity. Let's verify this option. Here, since a to the power k equal to identity, that means obviously this is the annihilating polynomial. This is with the annihilating polynomial of the linear transformation A, who is mapped from complex number to complex number, because here given AB n cross n complex matrix which satisfies this equation, and k is the any positive integer who is greater than 1, and since this is the annihilating polynomial, that means x to the power k minus 1 equal to 0, which is equal to x minus 1 times 1 plus x square plus x cube, and this would be continue plus x to the power k minus 1 equal to 0. That means possible minimal polynomial is either x minus 1 or x 1 plus x here would be also x plus x square, x plus x square plus x cube up to x to the power k minus 1 equal to 0, and other possibility is whole part x minus 1 times 1 plus x square up to x to the power k minus 1 equal to 0. But here given in the question 1 with the not is not eigenvalue of the matrix A. So all of us know the root of the minimal polynomial is the eigenvalue of the matrix. So we cannot take x minus 1, because if the minimal polynomial is x minus 1, that means A equal to identity. So 1 with the eigenvalue of the matrix A. Similarly, we cannot take this also, because this imply 1 with the eigenvalue. That means only possibility is this. And since this is the minimal polynomial, so all of us know minimal polynomial always annihilate this equation. That means this would be a plus a square plus a cube up to a to the power k minus 1 equal to just minus identity. That means notice the second option. Second option imply a plus a square up to a to the power k minus 1 equal to 0. This is wrong option. And option 1 imply A is diagonalizable. Is it true? Since this is the minimal polynomial, we all of us know root of this equation always would be distinct, and this root belongs to complex number, then and the root would be such type x minus j1, x minus j2 up to x minus jk minus 1. So since there exists distinct root, so obviously the matrix A would be diagonalizable. Are you getting? Oh well. Option 1 is a right option, and option 3 implies trace of A plus trace of A square up to trace of A to the power k minus 1 equal to minus n. For this, apply trace on this equation is both sides. And we all of us know always be the linear operator, so this would be equal to trace of A plus trace of A square plus trace of A cube, and this would be continue, which is equal to plus trace of A to the power k minus 1, and since trace be the linear operator, so minus would be cancelled. That means this would be minus trace of identity, which is equal to actually minus n. That means from this equation, obviously option 3 is a right option. That means option 3 is a right option. Now apply the option 4. Observe the option 4. For option 4, multiply this equation both sides by a to the power minus k minus 1. Then this equation would be reduced as identity plus, this means a to the power a inverse plus, this would be continued, and here identity means a to the power minus k minus 1. So from this expression we can tell this would be a inverse, then this would be similar to a to the power minus 2, and this would be continue plus a to the power minus k minus 1 equal to minus identity. Are you getting? So option 4 is a right option. Are you getting this option? I hope my all viewers have understood. I have told you why the characteristic polynomial, minimal polynomial, this concept, and when the matrix be the diagonalizable, this concept actually very important for any competitive exam. If you know this concept in better way, then you can easily solve this type of question. So I have told you. Oh, I will highly recommend you, if you don't see my previous video, at first see my previous video, then this concept you will understand in better. Discuss another question which had come CSIR NET June 2015 exam. This question depends on characteristic polynomial. The question is, consider the matrix A, which is 3 cross 3 matrix, and here this A, B, C, D be the integer. Then we must have option 1, if A not equal to 0, then there is a polynomial P in QX such that PA is the inverse of the matrix A. Option 2, for each polynomial Q in ZX, the matrix QA equal to such type. Option 3, if a to the power n equal to 0 for some positive integer n, then that imply a cube equal to 0. Option 4 imply A is commute with every matrix which is of the form such type. First option, if A not equal to 0, here has indicate there is a polynomial P in QA such that PA is the inverse of the matrix A. That means PA is the inverse, that means PA times A would be identity. For this, we all of us know, for n cross n matrix, the characteristic polynomial is x to the power n minus s1 x to the power n minus 1, and this would be continue plus minus 1 to the power n Sn. Where obviously S1 means trace of this matrix and Sn means determinant of the matrix, and other Sk is the all principal minor of order k. We have to prove for this matrix, if a not equal to 0, then there is a polynomial P in Qx such that Pa is the inverse of the matrix. Obviously by these rules, characteristic polynomial of this matrix would be x cube minus 3x square plus x times a square plus a square plus a square minus a cube. That implies x cube minus 3ax square plus 3a square x minus a cube. By a characteristic polynomial, we all of us know every matrix annihilate this polynomial. Then this would be a cube minus 3a square plus 3a square a minus a cube I equal to 0. And from this expression, this imply a cube identity equal to capital A cube minus 3a square plus 3a square a. That means identity equal to 1 over a cube times capital A cube minus 3 times 1 over a square a plus 3a equal to a. And if we do common a from this equation, then this would be a times this expression. And notice here identity equal to a times this. Inverse means obviously PA would be PA times A would be identity. We can tell PA is the inverse of the matrix A. Okay, that means here PA equal to 1 over a cube times a square minus 3 over a square times a plus 3 over a times what? Are you getting what is the PA? OL. Means obviously option 1 is the right option. If a not equal to 0, then there is a polynomial P in Qx such that PA is the inverse of the matrix. Option 2, for each polynomial Q in Zx, the matrix QA would be such type. This would be true. If we consider a polynomial Qx equal to x square, then here Qx equal to x square, that means obviously QA would be a square, and a square means this matrix, just calculate. But even QA equal to this matrix, but this matrix just put the value. I have considered Qx equal to x square, that means QA would be a square, QB would be b square, QC would be c square. Here also a square, d square, a square. And notice QA and this matrix is different matrix. So QA cannot be equal to this matrix. Still, option 2 is a wrong option, because option 2 imply for each polynomial Q in Zx, the matrix Qx would be such type. And third option, if a to the power n equal to 0 for some positive integer n, then that imply a cube equal to 0. Obviously, this is property of nilpotent matrix. This is always true, because if for n cross n matrix, if a to the power k is 0 for some k belongs to n, then that imply always a to the power n equal to 0. We all of us know this is the property of nilpotent matrix. So obviously the third option is true. Option 4 imply a commutes with every matrix which is look like such type. For this, since here have given the matrix A is commutes every matrix which be the from such type. This is A. Then consider this matrix as S. Then obviously it would be AS equal to SA, but AS equal to this matrix and SA would be this matrix. Notice these value are equal value. That means obviously the matrix A is commute with such type of matrix everywhere, because here A dash, the value of A dash C dash are non-zero number. So this value is always equal. A is equal to ASA. That means 4 is a right option. A commute with every matrix which is look like such type. Are you getting? Oh well. Now I will discuss one easy type question. This question easy, but this type of question actually very important for any competitive exam. First question had come CSIR net June 2021 exam. The question is, consider AB 4x4 matrix such that with eigenvalue -1, 1, 1, -2. Then consider B equal to a to the power 4 minus 5a square plus 5. What would be the trace of A plus B? We all of us know trace of A plus B means obviously trace B linear operator. So this would be trace of A plus trace of B. And since here given the eigenvalue of the matrix A which is -1, 1, 1, -2. So obviously trace means sum of the eigenvalue. And notice B be a polynomial with A. So how we will find the eigenvalue of B? We all of us know, since this is the polynomial equation, if lambda be the eigenvalue of A, then f lambda be the eigenvalue of f of A. So corresponding to the -1, the eigenvalue of B would be 1 minus 5 plus 5. This is equal to 1. Similarly, corresponding to 1, the eigenvalue of B would be 1. Similarly also, because the eigenvalue of A is -1, 1, 1, -2. So also would be this 1. And corresponding to -2, the eigenvalue of B would be 1. So trace of B means 1 plus 1 plus 1 plus 1. So here trace is 4 and here would be for trace of A is -1. So this value would be 3. That means trace of A plus B would be 3. Are you getting? This is very easy type question. But here the actual concept is, if lambda be the eigenvalue of any matrix, then f lambda be the eigenvalue of this polynomial, and which is denoted as f of A.